This is Relatively Prime, Citations in the Mathematical Domain. I am Samuel Hansen. I know that I don't talk much about myself and what I do, beyond, of course, making this show. But for today's episode, I'm going to change that up a bit. Instead of talking with someone else about their work, I'm going to share with y'all some of mine. Since I started Relatively Prime, I've had a few different gigs. I've been a Kickstarter-funded podcaster, a healthcare software company data analyst, a produce tent cashier, a barista, and a graduate student. Now I'm the mathematics and statistics librarian at the University of Michigan. This means that I support the academic work, both research and education-wise, of the mathematics and statistics departments. This takes many different forms, from making sure that the collections are as strong as possible, to providing instruction about how to use the library, to helping lead reading groups in the departments. I'm not going to talk to y'all about any of that today. Instead, I'm going to talk about the research I've been conducting since starting as a librarian. This research is in an area known as scientometrics, which does literally mean measuring science. In particular, I have been doing bibliometrics, which is yet another fancy word, this time for measuring and analyzing data about research publications. In my case, that data is about citations within the mathematical literature. The reason that I'm interested in looking at these citations from within the mathematical literature is that I believe that there's patterns in these citations, and that if we look at these patterns, especially if we look at them from the 30,000-foot view, it can help us better understand the nature of mathematical research. Now, I'm not the first person or the only person who's ever thought to look at citation data by any means. It's just that no one else has ever really specifically looked at mathematics on its own. Normally, mathematics gets put into a science or STEM pile for the purposes of an analysis. Even with this, previous research has shown over and over that mathematics publications do not seem to act in the same way as the rest of STEM. Specifically, mathematics seems to cite older research much more often than other fields. This different behavior has not been enough to spur on deeper research so far, though. Of course, mathematics citing older work makes total sense when you think about it. Unlike, say, medicine, where a 10-year-old paper about a treatment could very well be out of date and irrelevant to new research, a 10-year-old proof, if it was done correctly in the first place, is just as correct and just as relevant as it was when it was first published. In fact, the same could be said for a 50 or 100-year-old proof. Hell, we still teach proofs that we credit to Euclid, and those are over 2,000 years old. This isn't to say that mathematics does not age at all. While older mathematics can still be just as correct in a way that older works in other fields may not be, more recent mathematics is still more likely to get cited than older mathematics, simply because it's more likely to be similar to the work that's currently being done, and therefore it's going to be more useful for today's mathematicians. So we know mathematics ages, but that it ages more slowly than other fields, which of course leaves us with the question of, how slowly does it age? And that is a question that I might just have some answers for you about. Before I give you those answers, though, I want to state that the only reason I've been able to come up with any sort of answers for these questions is that I happen to work for a Big Ten school, because the Big Ten Academic Alliance helped its members purchase a version of Claravit's Web of Science, which is a well-respected database of scholarly works and their citation data, which is what I have used for my work. This data covers publications from 1900 to 2017, and it was processed into a usable format with some help from the Cadre group, whom I truly owe my deepest thanks. With all of that said, let's get to those potential answers. I started with a traditional measure of aging, just looking at the median citation age for publications. Previous studies of this type have tended to focus on all the publications for a specific year or over a specific time window of, say, 24 years. But since my interest about mathematics was how slowly it ages, I didn't want to restrict how old citations could be. And I wanted to be able to see how that median citation age changed over a long period of time. So I decided that I wasn't going to restrict my dataset at all. This decision was computationally expensive, but it did show some interesting patterns, which made it worth it to me. I will be honest and say this is the sort of thing which is a lot easier to show you visually with a plot of median citation ages over time than it's going to be for me to explain it with words, but I'm going to give it a go anyway. If you want to see that plot of the median citation ages over time, I will put it in the show notes for this episode at relprime.com/citation aging. That's relprime.com/citation aging, all lowercase. So, for more recent publications, the median citation age climbs to about 15 years, and it holds steady about there for papers published between 1995 and 1970. And then the age begins to increase linearly until it's over 80 years old for research published in 1900. Okay, so you have a basic idea in your head now, but in order to try and make it more concrete, I'm going to try a little bit of an experiment and play for you a sonification of this data that I made using Jonathan Middleton's Musical Algorithms website. You may remember Jonathan from Season 1's episode, The Score About Mathematics and Music. This sonification will go from the year 2019 to 1900. And the older the median citation age is, the higher the pitch. See how it starts really low, climbs a bit higher, steadies out, and then gets really high? That is the median citation age curve for mathematical papers in the Web of Science. Of course, that just tells you what mathematical citation aging dynamics are. It doesn't tell you anything about how unique it is. In order to show that, I decided I was going to do the exact same analysis, but for physics. Let's listen to physics curve now. So it sort of starts low and gets a little bit higher, maybe around the mid-range, but nowhere near as high as mathematics. I mean, just looking at the citations of physics papers from the year 1900, the median age is under 30 years old. So the gap in the year 1900 is over 50 years between the median citation age of mathematics and physics. To get a better sense of what this really means, let's hear the sonifications together. Sounds even more stark than hearing the numbers, doesn't it? Knowing the median citation age for all the mathematical publications in each year was awesome. But this analysis seemed to be missing something for me. It's related to something that I said earlier, that newer publications are more likely to pick up citations as they are more related to current work. This, of course, means that as time goes on, a paper gets cited less and less, and each citation will have a smaller and smaller impact on that median citation age. This is, of course, what we're looking for from medians, a norm that's not heavily impacted by outliers. But in some cases, there is an argument to be made that outliers can tell us something important. I feel that citation aging is one of those cases. In particular, I wanted to know the most recent time that a publication had been cited, or in other words, its oldest citation. After some more computational expenditure, I calculated the oldest citation for all mathematical publications in the Web of Science, and then took the median of those oldest citations for each year from 1900 to 2017 again. For mathematics, this yielded a plot that's pretty much aligned with slope -1 from around 110 years old for publications in the 1900s, all the way down to 0 years old for publications from 2017. Here it is sonified. This means that for older mathematics publications in Web of Science that had been cited, half of them had been cited since around 2010. That may not sound like much, but it's actually rather incredible and one of the best signs of just how slowly mathematics ages. Especially since it's around 2010, whether the cited publication was from 1900, 1940, or 1980. For comparison, let's again hear physics. As you can hear, the median oldest citation plot for physics is a bit more all over the place. For newer publications, it's very similar to mathematics, with the nearly -1 slope line from around 20 in the mid-1990s to the 0 in 2017. But from 1900 to the mid-90s, the plot jumps around a lot. If we were to smooth it out, it would be a line from around 1966 years old to 1995 and 18 years old, which would be a line with a slope around -1/2. That's half the slope of mathematics, and it certainly represents a very different aging dynamic. Think about the 1900, 1940, 1980 comparison. Instead of around 2010 for all of them, in physics, half the cited papers in 1900 had been cited since 1966, which becomes 1987 for 1940 and 2005 for 1980, which, as I said, is very different from the mostly steady state of 2010 behavior of mathematics. In fact, it's even stranger than that makes it seem, as it's not until the 1930s that the median oldest citation in physics is regularly older than the overall median citation age in mathematics. That's right, a random citation chosen between 1900 and 1930 in mathematics is likely older than a random oldest physics citation from the same year. And if that doesn't convince you that mathematics and physics age in two very different ways, maybe playing the sonification of those two curves together will explain better than my words can. This is still very new research. In fact, this podcast episode is the first time I've spoken publicly about it outside of a couple of conferences. So this could even be considered breaking research news in a world quite unlike our own, with a much different and slower news industry, of course. This means there's still a lot I don't know about the aging of mathematical citations, and I bet that you have a bunch of questions that I am not yet ready to answer. But I'm going to keep on working on this, and I am looking so forward to finding out more and sharing those new answers and results with you here on Relatively Prime. So that is all the time we have here on Relatively Prime. There is no guest to thank this week, so I want to thank Jonathan Middleton for the musical algorithms webpage, which allowed me to make the sonifications of the data that I played for you on this episode. I also want to thank Lowercase N, whose music I played at the beginning of the show, and I'm playing again right now. I also, and this is truly most of all, want to thank my patrons on Patreon. How y'all doing? You are the best. Couldn't make the show without you. Literally, I would not be making the show without my patrons on Patreon. So I think y'all should probably want to thank them all too. And if you want to join them, you can always head on over to patreon.com/relprime or relprime.com/support. And do what you can to make sure Relatively Prime can keep on existing. If giving money is out of the cards, I totally get it. I have been there multiple times in my life, as that list of gigs that I've had while making Relatively Prime probably made especially clear. I can tell you, Produce Tent Cashier does not make you that donating to podcasts kind of scratch. But there is still something you can do, which is, of course, head on over to your podcast app of choice and leave a review for Relatively Prime and tell people how cool it is to hear stories about math. Because that is how a bunch of people will know to check out the show, especially now that there's new categories which actually include mathematics as a subcategory of science. Thank you, Apple. It only took you 14 years. So that is it, other than telling you that Relatively Prime is licensed under a Creative Commons Attribution Share-alike license, so you can feel free to do whatever you want with this audio as long as you say that you got it from Relatively Prime and share it in the exact same way. Haven't heard a new weird remix of Relatively Prime recently, so please feel free to do that and share it with me. And now, to close, as always, and forever, I hope y'all have a matherific month, y'all.